let's begin. We have limit as x approaches infinity of 2 root x plus x to the negative first power over 3x minus 7. The first thing we want to do is to identify the highest coefficient, or the highest term of the bottom. So the highest term involves the x here. So we're going to multiply top and bottom by 1 over x. When we do that, we distribute the 1 over x to both the 2 root x and the x to the negative first power. So we're left with limit as x approaches infinity, and we'll have 2 over root x plus 1 over x squared over 3 minus 7x. Now as we take x to approach infinity, 2 over a really big number, 1 over a really big number, and 7 over a really big number will go to 0. So we're left with 0 over 3, and 0 is our limit. Let's try another one. We have limit as x approaches infinity of 2 plus root x over 2 minus root x. Here, some students will multiply by the conjugate, but a better way to do this problem is to, well, first let's see what happens if we multiply by the conjugate. So if we multiply by the conjugate of the bottom, we'll get 2 plus root x and 2 plus root x. So we'll have limit as x approaches infinity. So we'll FOIL out the top. We'll get 4 plus 4 root x plus x over 4 minus x. And here we'll get infinity over negative infinity on the bottom. So we would have to divide by x. So we'll have to multiply by 1 over x, because x on the bottom here is the highest degree. So you'll have limit as x approaches infinity, 4 over x plus 4 over root x plus 1 over 4 over x minus 1. And now 4 over x goes to 0, 4 over root x, and 4 over x will go to 0, so we'll be left with negative 1. So we get an extra step just to FOIL it out. So this will be the first step, to multiply by the conjugate, FOIL it out by multiplying by 1 over x. But what we can do from the beginning is skip to step number 2. So we can go to this step by first understanding that we can divide everything by the highest exponent, or the highest degree of the bottom, which is the root x. So let's take a look at that. So let's redo this problem. We have limit as x approaches infinity of 2 plus root x over 2 minus root x. Here I'm going to multiply, multiply top and bottom by 1 over root x. So I'm left with limit as x approaches infinity. Now the 1 over root x distributes to both the 2 and the root x. So we're left with 2 over root x plus 1 over 2 over root x minus 1. And now these will go to 0. And we'll have 1 over negative 1, and so our limit is negative 1. So it's better to skip that step of multiplying by the conjugate. Okay. Next, what happens if we have different exponents on the bottom, different radicals? So limit as x approaches negative infinity of cube root of x minus cube root, or fifth root of x over cube root of x plus fifth root of x. This looks complicated, but all we have to do is decide which term is bigger. Is cube root of x bigger than fifth root of x? Well, we can write it as x to the 1/3 and x to the 1/5. The higher the exponent, the bigger the number. So yes, 1/3 is greater than 1/5, so we say that x to the 1/3 is greater to x to the 1/5. So that means we're going to multiply top and bottom by x to the 1/3. Sorry, 1 over x to the 1/3. Yeah. 1 over x to the 1/3. Okay, so let's try this. Limit as x approaches negative infinity. Now, if I distribute the cube root of x, so that would just cancel, we'd be left with 1. And then I'll multiply fifth root of x with 1 over x to the 1/3. I can rewrite that as x to the 1/5 over x to the 1/3. And here I can subtract the exponents. It'll just be x to the 1/5 minus 1/3, which will be x to the negative 2 over 15, which is 1 over x to the 2 over 15. So I'm going to rewrite it as 1 over x to the 2 over 15 over, now cube root of x's here are going to cancel, and I'm going to be left with, again, 1 over x to the 2 over 15. So x over 2 to the 15th power will approach infinity when x approaches negative infinity. So it'll be 1 over a really big number. Well, this will just go to 0. And so will this. And all I'm left with is 1. So my limit here is only 1. Okay, now let's try a similar one, but instead of having different radicals, we'll have different integer exponents. So we have limit as x approaches infinity, x to the first plus x to the negative fourth over x to the negative second minus x to the negative third. The first step is always to identify which is the biggest term of the denominator. We have two choices. It's either x to the negative second or x to the negative third. We compare the exponents. We know that negative 2 is greater than negative 3. So we know that x to the negative second has to be greater than x to the negative third. So that's the highest exponent, or highest term, right here. So we'll multiply top and bottom by 1 over x to the negative second power, which is really the same thing as multiplying it by x squared. So I have limit as x approaches infinity. So we'll do x to the negative first times x to the negative 1 over x to the negative second. So that's the same thing as saying 1 over x times x squared, which is just x, plus x to the negative 4 is 1 over x to the fourth times x squared will give me 1 over x squared. X to the negative second times 1 over x to the negative second. Well, the x and negative seconds are going to cancel. We're going to be left with 1. And x to the negative third is 1 over x cubed times x squared, and that's just 1 over x. Okay, here we notice that, let's see, 1 over x squared goes to 0. 1 over x also goes to 0. So we're left with limit as x approaches infinity of x. And we know the limit there is infinity.